Hello everyone, welcome. In this class, we will study about calculation of lattice energy. In the previous class, we have talked about what is lattice energy and how to determine the different solids, which one will have higher lattice energy and which one will have the lower. We discussed about the different factors affecting the lattice energy. In today's class, we will talk about calculation of lattice energy. For this, we need to study the Born-Haber cycle. Which uses the Hess's law. Hess's law says the net enthalpy change of a chemical reaction or of any process always remains same whether the reaction takes place in one step or many steps. For example, if I talk about reaction is happening from A to D, and suppose for this change the enthalpy change or the energy change is x kilojoule per mole. For this reaction, the enthalpy change is x kilojoule per mole. Now, this is a direct process. This can go via B, this can go via C and D. So for this, there is Y, there is Z, and then there is P. So the reaction is taking place from A to D. There can be a direct process from A to D, or it can go via A to B, then B to C, then C to D. For A to B reaction, the energy change is Y. From B to C, it is Z, and from C to D, it is P. So according to Hess's law, the summation of Y plus Z plus P should be equal to X. Whether the reaction takes place in one step or in many steps, the total enthalpy change will remain the same. You can take this example. Suppose you're going from your school to your home. So what you can do, you can go by school bus, okay? You can go by walk, or either you can take help from your friend. Suppose that friend is on scooty and you hop in on the scooty and you go via that. And you're going from, suppose ultimately you're going from school to your home. But in between you're stopping at the library, or else you're stopping at the restaurant to eat something, or ultimately you'll go back to your home. So the final destination is same. So what do we do in Hess's law? Whether the reaction takes place in one step or in many steps, the total enthalpy change remains the same. It is very important question for JEE point of view or NEET point of view. For example, if we talk about Born-Haber cycle for NaCl. In last class, we had talked about standard states. What are standard states? The standard state is the state in which the element is present in the heat of formation is zero. But if you are not aware of it, you will talk about it more in thermodynamics. But in case of Born-Haber cycle formation, we will take a good use of it. So, जो sodium है, the sodium metal is present in this sodium solid, and the chlorine is present in the Cl2 gas. These are called standard state. And from this standard state, we form NaCl solid. What is this called? This is called enthalpy of formation. NaCl बनाने के लिए तो यहाँ पे half लगेगा Cl2 because we need only one Cl atom. So this is called enthalpy of formation. Enthalpy of formation. Write down in your notebook with me. This is our enthalpy of formation. Now, what will happen if we talk about if the Na solid reacts with half Cl2 gas molecule, how it goes by? First of all, what do we have to do? We have to convert the solid into the Na gas. And when we convert solid into gas, guys, what is the process? Solid to gas directly, it is called sublimation, right? So we will write this is enthalpy of sublimation. Now the sodium gas will become Na plus gas, by loss of electron. This is called ionization energy. Right guys? In case of half Cl2, पहले half Cl2 molecule है, इसको हम Cl atom में बनाएंगे. So what we can do? We can convert this into Cl gas. So what is this called? This is called bond energy dissociation. Bond dissociation energy. अब एक Cl molecule को तोड़ेंगे तो दो Cl बनेगा. ध्यान से सुनिए. When we break one molecule of C2, we are getting two atoms. So if we need only one Cl atom, we need to break half of it, half of Cl to get molecule. So what we'll do here, we will put half of the bond enthalpy. क्योंकि एक पूरी bond enthalpy यूज करेंगे तो दो Cl atoms बनेंगे, पर हमें NaCl बनाने के लिए सिर्फ एक Cl atom चाहिए, तो हम उसका क्या करेंगे? Half of bond energy. ओके उसके बाद जब Cl गैस एटम बन गया तो उसके बाद हम इसे कन्वर्ट करेंगे इन द एनोयन. वी नीड टू कन्वर्ट द Cl gaseous atom into the anion. So what we will do, we'll make it gain one electron. What is this is called? This is called electron gain enthalpy. Electron gain enthalpy. Now what will happen? This is sodium gas and Cl minus gas. These two will combine and this will form NaCl solid. This is called lattice energy. When the gaseous cation and anion combine to form the NaCl solid, that is called lattice energy. Now, just now we have talked about Hess's law, right guys? So Hess's law क्या कहती है? Hess's law कहती है whether the reaction is taking place in a single step or in many steps, the total enthalpy change remains the same. So look at this. This is the direct process. And the enthalpy change is heat of formation. Now, we have so many steps here. Conversion of this, and then finally this. So what we can do, you can write down in your notebook, delta H formation is equal to delta H sublimation, sodium, delta H ionization energy, good, half of bond energy plus electron gain enthalpy plus lattice energy. These so many steps will form formation. Of heat of formation, if we look at the signs of these energies, sublimation we always have to supply the energy, so it is always positive. Ionization energy we always have to supply, this is positive. Bond energy, to break something we have to supply something, so again this is positive, हमें supply करनी पड़ेगी. Electron gain enthalpy, depending upon what type of anion we are talking about, it can be positive or negative. And जो हमारी lattice energy होती है वो भी उसका साइन हमें देखना पड़ता है, और हीट ऑफ फॉर्मेशन भी पॉजिटिव और नेगेटिव हो सकती है. ओके, write down in your notebook. So in the numericals you will find the values given and they will ask you find out the lattice energy. So any of these of one of them can be asked calculate in the exam. But if only when you know that this is the process, then only you will be able to find out. No, if you don't know how to go about it, then how will you find out? Right? Let's talk about Born-Haber cycle for magnesium chloride. Think about it. How will you go about this? Similarly that we made for NaCl, we have to make similarly like this. Magnesium is present in which state? Mg solid, Cl2 gas will form MgCl2 solid. अब हम यहाँ पे half Cl2 नहीं लेंगे बिकॉज वी नीड 2 Cl atoms in the MgCl2 formula. Okay, so don't do the half thing. First of all, the magnesium is converted into magnesium gas. This is called enthalpy of sublimation. Then magnesium gas is converted into magnesium 2 plus ion. Yes or no? So we have to add, like the magnesium will give out 2 electrons. So there will be 2 ionization energy. Ionization energy 1, ionization energy 2. Yes or no? Okay, because magnesium से magnesium 2 plus ion बनाना है तो हमें 2 electrons बाहर निकालने पड़ेंगे magnesium से, इसलिए we are considering ionization energy 1, ionization energy 2. Cl2 से हमें 2 Cl गैस बनाना है, so this will be bond energy full. Okay, then इससे हम क्या करेंगे, 2 Cl गैस बनवाएंगे. This is called electron gain enthalpy. अब क्योंकि 2 Cl यूज हो रहे हैं, we will be using 2 electron gain enthalpy. Understand this? Okay. उसके बाद क्या होगा, this magnesium 2 plus will combine with 2 Cl minus to form this, and this is called lattice energy. So we can write down the formula here. Delta H sublimation plus delta H ionization energy 1, delta H ionization energy 2 plus delta H bond enthalpy of Cl2 plus 2 electron gain enthalpy of chlorine plus lattice energy will be equal to heat of formation. This will be equal to the heat of formation. Right, guys? This is the Born-Haber cycle for magnesium chloride. Now we can talk about Born-Haber cycle for aluminum oxide. Born-Haber cycle for aluminium oxide. अब aluminium oxide बनाना है. Aluminium is present in solid form. Oxygen हमारे पास एटमॉस्फेयर में O2 मिलती है, ये इनकी स्टैंडर्ड स्टेट्स हैं. And this will form Al2O3. Look at the formula, guys. So we need 2 aluminiums. यहाँ पे 2 aluminium लगा दीजिए. We need 3 oxygen. 3/2. Yes or no? Okay. This is our heat of formation for this process. Now what we'll do? We'll talk about the Born-Haber cycle. First of all, we'll convert it into Al gas. This will be twice of enthalpy of sublimation because there are 2 atoms involved of aluminium. उसके बाद हमें इसको क्या बनाना है, एल्यूमिनियम 3 प्लस. एल्यूमिनियम 3 प्लस बनाने के लिए बेटा कितने आयनाइजेशन एनर्जीज लगेंगे, 3. तो वी कैन से डेल्टा H आयनाइजेशन एनर्जी 1, डेल्टा H आयनाइजेशन एनर्जी 2 प्लस डेल्टा H आयनाइजेशन एनर्जी 3. अब हमें क्या करना है, ऑक्सीजन को तोड़ना है. हमें 3 ऑक्सीजन बनाने हैं. अब 3 ऑक्सीजन बनाने के लिए हमें 3/2 O2 मॉलिक्यूल को तोड़ना है. देखो ये O2 मॉलिक्यूल है ऐसा, इसको तोड़ के हमें ऐसे बनाना है. सो एक मॉलिक्यूल को तोड़ के 2 बनता है, तो 3/2 को तोड़ेंगे तो कितना बनेगा, 3/2 into 2 यानी 3. तो हम इसको कैसे लिखेंगे, हम इसे लिखेंगे 3/2 ऑफ एंथैल्पी ऑफ बॉन्ड एनर्जी. अब इसके बाद हम क्या करेंगे, इसके बाद इसे इलेक्ट्रॉन गेन एंथैल्पी करवाएंगे. इलेक्ट्रॉन गेन एंथैल्पी में इसका ऑक्साइड बनाएंगे, यानी 2 इलेक्ट्रॉन कराएंगे. हम लिखेंगे इलेक्ट्रॉन गेन एंथैल्पी 1 प्लस इलेक्ट्रॉन गेन एंथैल्पी 2. एक ऑक्सीजन की तो टोटल 3 है, यहाँ पे 3 लगाएंगे. अब उसके बाद हम ये देखेंगे कि इन दोनों को कंबाइन कराएंगे. ये हुआ, उसके बाद दिस इज डेल्टा एच लेटिस एनर्जी. So what we can write down here? We can write down delta H sublimation twice plus delta H. और इस केस में देखिए 2 एल्यूमिनियम थे तो इसको करेक्ट कर लीजिएगा, ये 2 होगा तो इस सब का भी 2 ही लगेगा. So twice of ionization energy 1, twice of ionization energy 2, twice of ionization energy 3. Why guys? Because there are 2 aluminum atoms involved. Okay, here. उसके बाद we'll add it with 3/2 of bond enthalpy of oxygen plus 3 into electron gain enthalpy 1 plus 3 delta H electron gain enthalpy 2 plus delta H lattice energy, and this will be equal to heat of formation. Guys, this expression is bigger than the previous one, so we have to be very careful here. Okay, all right. Now let's talk about the bond Haber cycle for NABR. Again interesting. So NABR, Na solid. What is the standard state of bromine? Understand, bromine standard state is liquid. So half of it NABR solid. Very important for NEET and JEE. Many of the students, they lied Br to gas. Understand, chlorine is the standard state of chlorine gas is gas, but for bromine it is liquid. Okay, what is this? This is enthalpy of sublimation. Then this Na plus gas. What is this? Ionization energy. Then what we'll do? We'll try to make Br to gas. So for liquid to gas, the process is called vaporization. So half of the molecule is involved. So we will write half of the enthalpy of vaporization. Then Br2 will be converted into Br gas. What is this process called? Bond energy. So half of the bond energy. Then this will be converted into Br minus gas. This will be electron gain enthalpy or electron affinity. Okay, electron gain enthalpy. Now this and this, these two will combine. Okay, you can write it like this. These two combine. Form this via lattice energy. So we can write the expression for this process. Write down in your notebook, and for this it is enthalpy of formation. So we can write enthalpy of formation is equal to sublimation, okay, then ionization energy, then half of the enthalpy of vaporization, then we have half of the bond energy. Then what do we have? We have electron gain enthalpy, right guys? Write down. Plus lattice energy. So this is the Born-Haber cycle and the final expression for NaBr. So the catch point is bromine's state is liquid, not gas. So पहले liquid से आपको Br2 gas बनाना पड़ेगा using half of the enthalpy of vaporization. Okay, this was the catch and this is very important. Please do remember this. Now let's do the Born-Haber cycle for NaI. So sodium iodide, sodium is present in solid. What is the standard state of iodine? Solid. Very good. So what we'll do? First of all, we will convert this into gas. This is enthalpy of sublimation, and this will convert it into Na plus gas, enthalpy of ionization. In this case, iodine can be converted into I2 gas. This is enthalpy of half of the enthalpy of sublimation. Okay, and then this can be converted into I2 gas, half of the bond energy, and this will be converted into I2 minus gas. This is electron gain enthalpy. Now this and this combines to form NaI. This is called lattice energy. And what is this? Enthalpy of formation. So what we can write as the expression? Write down in your notebook, guys. Enthalpy of formation is equal to enthalpy of sublimation of sodium plus electron enthalpy plus half of the enthalpy of sublimation of I2. This is I2 and this is for sodium. Okay, then we have half of the bond energy of I2 plus, and we have electron gain enthalpy of I2 plus lattice energy. This is the expression for NaI.